for the pattern 1010, and we are considering this time non-overlapping. That means we have to check the sequence 1010 when there is a non-overlapping pattern sequence. So for example, we have certain input that are coming continuously like 10101010101010 like this, any pattern we are receiving. Now if it is a non-overlapping, so whenever you detect a correct sequence like here 000, we will receive 1. So when you receive, as we are receiving 1010, whenever you receive 1010 correct pattern, then output will be 1. And once you receive the correct pattern, you have to initiate your search from the beginning. So here 000000001. Whenever again I am receiving the correct pattern, that is 1010, my output becomes 1. After detecting the correct pattern, you have to again initiate from the beginning. So 0000001. Whenever again I will receive the correct pattern, my output will be 1. So this is the way by which you are detecting the particular pattern in case of non-overlapping. Now we will see how to make a Mealy machine. So for the Mealy machine, my first step is state diagram. State diagram is very important in case of Mealy machine. So as we are detecting 1010, okay, in case of non-overlapping, always initiate from the state A. When you receive the first bit correct, that is 1, you have to move to the another state, that is B. When you receive the second bit of that pattern correct, 1/0, because this is the first bit that we received, and as we have not received the correct pattern of 1010, your output is 0. When you receive the second bit correct, that is 0, you will move to the another state, that is C here, and here you will write down 0/0 because my second bit is what? 0. And after C, if you receive 1, then you will move to the D state, that is 1/0. After that, you have to check whether it is a non-overlapping or no-overlapping. As in this case, we are considering non-overlapping. So when you receive the last bit correct, that is fourth bit, you have to come back in the initial state, that is A. And here you write down 0/1. When you receive 1010, then only you have to come back to the initial state in case of non-overlapping. Now, whatever we have seen is true when we see only the correct pattern. But what will happen if you are having the wrong bits input? Then what will happen? If you are in the state A, there is a chance of two types of input, either 0 or 1. So we have already checked for 1 and I moved to B state. But if you are getting continuous zeros, that means I have not yet received a single bit correct, and I will remain in the same state, that is A. So 0/0. B means one more important point. A means 0 bit correct, B means 1 bit correct, C means 2 bit correct, and D means 3 bit correct. So if you are in the state B, that means we already receive a single bit correct, that is 1. And we have checked after 1, if I will receive 0, I will move to the C state. That's okay. But what will happen if I am getting 1 again? If I am getting 1 again, then it's also mean we have a single bit correct, because after that I require 1010, right? So in this situation, when you are getting 1, here also we have a single bit correct only. So you have to remain in the same state, that is B, and here you write down 1/0. Now if you are in the state C means we already have received 2 bit correct, and I was waiting for 1. If I will get 1, I will move to the D state. But what will happen if I will receive 0? 0 means complete loss of pattern, because again after this I require 1010 for the correct pattern. That means we have to initialize from the beginning, because now the pattern is lost, and here you will get 0/0. Now, if you are in the state D, that means we have 3-bit correct, that is 101. And I was waiting for 0. If I will get 0, I will move to the state A. But what will happen if I receive 1? If you receive 1, that means in this situation, I have only a single bit correct, because after that again I want 0 1 0 for the correct bit pattern. So that means we have only a single bit correct if I will get 1 after this. So single bit correct state is B, and here you will write down 1 by 0. So this is the complete state diagram for 1010 in case of non-overlapping. Now I will make the state table. So here I am drawing the state table, and for this is the second step here. For the state table, you have to write down present state, then here input, then next state, then output, and then output is represented by Z. Similarly, input will be represented by X. How many states are there? Total 4 states are there. So I'm making 4 lines here. 1, 2, 3, and 4. Here I'm writing A. Why? Because in the state A, the input can be either 0, 1. That's why I'm writing 2 times. Similarly, B. Here also input can be 0, 1. C. Here also input can be 0, 1. And in D state also, either the input can be 0, 1. If you are in the state A and you are getting 0 as an input, if you are in state A and you are getting 0 as an input, A and 0 as an input, so next state will also be A only. If you are in state A and you are getting B as an input, 1 as an input, then the next state will be B. If you are in state B and you are getting 0, so 0, you have to move to the C state. And if you are in the state B and you are getting 1, 1 means directly in the same state, that is B. If you are in state C and you are getting 1, you have to move to the D state, D. If you are in the state C and you are getting 1, C to 1, D. Sorry, C to 1 is D. C to 0. C to 0 is A. That was A. Similarly, if you are in state D and you are getting 0, D to 0 is A. D to 0 is A. And D to 1 is B. So AB, CB, AD, and AB. Now, as you know that in the digital design, we cannot represent by any alphabets. We have to always represent in terms of binary. So as we are having 4 states, we require 2 bits to represent every state. So here A is represented by 0 0 0 0, B is represented by 0 1 0 1, C is represented by 1 0 1 0, D is represented by 1 1. Similarly, as we are representing A as 0 0, A is 0 0. Wherever you have A, you write out 0 0. A is equals to 0 0. B is represented by 0 1, so this is 0 1, this is 0 1, this is also a 0 1. C is represented by 1 0, C is represented by 1 0, and D is represented by 1 1. Now we have the next state and output. So output is 1 only when you are moving from D to A. Whenever you are moving from D to A, your output is 1. For all other combination, you see output is 0 only. So from only D to A, from D to A, from D to A, your output is 1. For all other condition, it's 0 only. Correct? So now, for example, in this case, if you are designing the Mealy machine by using D flip-flop, for example, I'm using D flip-flop, we require the transition table of D flip-flop. So here I'm drawing the transition table of D flip-flop, excitation table of D flip-flop. If you are designing the Mealy machine by using D flip-flop, then you require excitation table of D flip-flop. If you're designing by using JK flip-flop, then you require excitation table of JK flip-flop. So here it is Qn, this is Qn plus 1, this is the value of D, 0 0 1 1 0 1 0 1. Output will be 0, 1, 0, 1. So the best part here is what? Whatever will be the next state, it is similar to your D. Now you compare the values. Here I am considering this is Q2, this is Q1. Similarly, this is Q2 plus 1 and this is Q1 plus 1. Just to tell this is the present state and this is the present state and this is the next state. Q2 and Q2 plus 1. Now here we have to compare the Q2 and Q2 plus 1 and find out the value of D2, right? And in the excitation of D2, D flip-flop, we have seen whatever will be the next state, you will get as a output D2. 0, 0, 1, 0, 0, 1, 0, 0. This is your D2. Similarly, you can find out the value of D1. D1 by comparing Q1 and Q1 plus 1. So this will be 0, 1, 0, 1, 0, 1, 0, 1. Right? So now we have all the values, but in the third step, we need to find out the expression for D1 and D0. So here we are finding in the third step, we are finding the expression of D2 and D1 in terms of Q2, Q1 and X. Okay, so now here you see how many input variables are there. Here we have Q2, Q1 and X. In terms of Q2, Q1 and X, we need to find out the expression of D2. As we have 3 inputs, 3 variable K-map is required to find out the expression using K-map. So here I am considering this is Q2, this is Q1 and X. This is 0, this is 1, 0, 0, 0, 1, 1, 1, 1, 0. Right? Now, wherever your function value is 1, you write down the expression. So this is 1, 2, and this is 5, 2 and 5. So you write 2 and 5. So this is 2 and this is 5. 1, 0, 1 is 5, 0, 1, 0 is 2. So we don't have the group here. Individual terms are there, and that is represented as Q2, Q1 bar X plus Q2, Q1 X bar. So this is the expression. This is Q2. Yes, Q2 bar. The Q2 bar, Q1 X bar, and this is Q2, Q1 bar X. This is the expression for D2. Similarly, we can find out the expression of D1. So D1, again, we have three input variables. So here I am considering this is Q2, this is Q1 X, 0, 1. As in the K-map, we use the gray code. Now you see where it's present. Whenever your D1 is 1, like here 1, 3, 1, 3, 5, 7, right? 1, 3, 5, 7. So 1, 3, 5, 7 will be represented as here 1, 3, 5, 7. So now you can see we can make a quad here, and the expression for this quad will be X. So now we have the expression. One more important point is Z. So Z can be represented here. You see Z. Z is 1 only when it's moving from D to A, right? So it's what? Q2, Q1 X bar. So it is Q2, Q1 X bar. It is Q2, Q1 X bar. Now we have all the expression and we have to draw the circuit diagram for this Mealy machine 1010 overlapping. At the top, I am drawing this is D2. So this is D2. Similarly, at the bottom, I will draw D1. This is D2 and this is D1. From here, you will get Q2. This will be Q1. And also, you have to draw the same clock to all the flip-flop because it's a synchronous circuit. So same clock I am giving to all the flip-flop. This is clock. And here I will get Q2 bar and here I will get Q1 bar. Now, what is the expression for D2? D2 is Q2, Q1 bar X. So here I am making two AND gates, 1, 2. Along with that, I have to give it to the OR gate. And this is the 1, 2, 3 terminals. Here also we have 1 and 2 and 3 terminal. This is Q2, this is Q1 bar, and this is X. This is Q2 bar, Q1 X bar. Similarly, what is D1? D1 is directly X, so you can write down X here. And with Z, it is Q2, Q1, and X bar. That we have to give to the AND gate. And whatever output you will get, that will be represented by Z. So this is the Mealy machine for 1010 non-overlapping.